Hello, algebra people. This video is for you to watch after you've done the Pear Deck on literal equations and introduction to it. This video is actually going to go through the notes with you. It's going to give you some hints, some examples, and then in class on Tuesday and Thursday, we will practice literal equations, getting to increasingly more difficult ones. So we're going to start with the slightly easier ones today. I'll give you some hints, and then in class, we'll work our way up to some more challenging ones. So like the Pear Deck said, we talked about what a formula is, and a formula is just an equation. Remember, an equation is different than an expression because it has an equal sign, and it's going to relate two or more quantities, usually represented by variables. And a variable is just a letter that stands for an unknown value. That usually you want to solve for the variable. Now, what you have been doing, and this is what the Delta Math homework review video number 2 showed you, is you have solved an equation with only one variable. It's usually x, and you're going to do whatever you need to do to get that variable alone. That's the old news. What you're going to do now is you're going to solve an equation with more than one variable in it. You can have 2 or 3 or 4, really however many you want. Make sure you write this down, pause if you need to get caught up. Now, our goal with literal equations, and some people don't call it literal equations. Some people just call it solving formulas, just so you know. Some books do call it literal equations, though. Our goal here is going to be to manipulate the equation to solve for one of the variables. So usually you will be told what variable to solve for. In this class, I'm going to tell you what variable to solve for. If you do this in a chemistry class or a physics class, depending on what you're looking for, that's going to be the variable that you solve for. Now, one thing to keep in mind is this isn't really that different than what you've been doing. It really is the same steps you learned back in 7th or 8th grade whenever you were solving regular equations. You're just going to have more letters now and less numbers. So you're still going to do something like adding 2's to each side, dividing by 5 on each side. All of those steps are the same, just not as many numbers. And the higher you go in math, usually the less numbers you have and the more letters you have. All right, so what we want to do is start with like a super simple one, just so you can see what our answers are going to look like. So let's start with the formula D equals RT. I'm going to try and use real formulas. Sometimes I make them up just to show you something that I'm interested in, but I will try to use actual formulas for math and science. And you might be thinking, hey, this looks familiar. This is the distance equals rate times time formula. Sometimes people call it DIRT to remember that it's D equals RT. And let's say I told you that I want you to solve for T. So again, this one's super simple. They're not really going to get much easier than this. I usually recommend people circle the variable you're looking for because otherwise you might go in an endless loop if it's a complicated problem. And to get T alone, we have to move R. Since R and T are connected with multiplication, we're going to divide by R on each side. And we're going to have distance over rate equals time. So again, that was super basic, but I just want you to realize that your answers are not just going to be a number or a decimal. They're going to be more complicated looking. They're often going to be fractions, and there's going to be many letters in your answer. So don't be alarmed if you see an answer that looks very complicated. That's perfectly fine. So let's go to another example, and let's do this formula. And these are going to bring back some good memories from your past math classes. A equals pi r squared. And you'll better remember what that formula is. That's area of a circle, and we're going to look for r. Okay, so if I want to get r alone, notice two things are preventing r from being alone on one side of the equal sign. We have this pi symbol here, and we have this squared here. So since we are connected with multiplication there, let's start by bringing pi to the other side. I divide by pi on each side. I now have a divided by pi equals r squared. Now, to get r alone, if it's squared, the inverse operation is to square root, and that's going to cancel. And then we're just left with r. So this one was just one more step than the previous one. Square root of a over pi. Now, as I do these problems, after certain examples that show something that I want you to remember especially well, I'm going to go to this hint sheet where we're going to write down some hints. And I find that sometimes when people do literal equations, they tend to give up because it just looks complicated. And you should never, ever give up on a problem until you have completely exhausted all of these hints and then some. Okay, so I'm going to pause here and write down this hint for you. Okay, so that hint number one for you, I wrote up here. So can you write that down in your notebook? I kind of added something else to it. If the variable is squared, you're going to square root each side. Those are inverse operations. If the variable you want is under a square root, then you're going to square each side. And I'm going to talk about why I put this in capital letters once the square root is alone, or I guess I should say once the squared term is alone. Let me show you two cases here where people make mistakes very frequently. Let's say I'm looking for the variable r in this case. What some people say is, oh, okay, r is squared, so I'm going to square root each side. But the thing is, you want to get that squared term alone first, which means you really should have moved 4 to the other side. And another mistake that people make is they're like, oh, okay, the square root of r squared plus 4 is r plus 2. They do the square root of each term. You can't do that when they're connected with addition or subtraction. So let me continue here with the mistake that they would make, and then they'd subtract 2. When really what they should have done is done all their subtracting and adding first, and then they would get r squared equals y minus 4, and then you would square root each side, and r would be the square root of y minus 4, which is not the same as the square root of y minus 2. These are not equal. So let me talk about the other scenario that people do. Sometimes people see this and they're like, okay, I'm going to square, let's say you're looking for p in this example, okay? And they're like, all right, well, p is stuck under the square root, so let me square each side. They like square first, and then they say, well, this would be the same as 7p because the square root and square root cancel, plus 121 equals m squared. And then they would subtract 121 and divide by 7, for example. But if you have the square root of 7p plus 11 squared, that's really the square root of 7p plus 11 times the square root of 7p plus 11, which means you'd really have to FOIL. And I know you're wondering, oh my gosh, Mr. Essie, do you have to write this out? This is taking forever. But you know what? Sometimes people need to see it done out wrong, because I find that people like do stuff without really thinking about what they're doing and what would actually happen. So it's good to see it done out incorrectly so you can really see why it's definitely not correct to do. So I have combined these two terms. They're radical terms, so you combine the coefficients. And as you can see, this is not the same as this. So in conclusion, you always need to make sure that the squared term or the square root term is alone first. So you should subtract 11, for example, and then square each side or do the square root of each side. Okay, let's do another example. That was a long hint right there. Example 3, how about we do p equals 2l plus 2w, and let's look for w. This is another geometry formula, and this one was for a perimeter of a quadrilateral, probably rectangle, square, etc. 2 length plus 2 width, and I want to solve for width. Now, I want to talk about a mistake that people make. And I know you're probably thinking, oh my gosh, all you're doing is showing me mistakes. But it's because people make mistakes when they learn on new topics. So I want you to avoid these mistakes. So hopefully by seeing them, you won't make them. One thing that people do is they think, all right, so I have this 2 in front of the w, so I'm going to divide by 2 on each side. And then they go on their merry way, and they say this, and then they subtract 2l, and they think that they're done. But let me write down this wrong answer so you can see what the right answer would be. So that's wrong. Let's go back here. P equals 2L plus 2W. The problem was they didn't divide the whole side by 2. And you need to divide the whole side by 2. And then 2L over 2 would be L. 2W over 2 would be W. Then you would subtract L from each side. So P over 2 minus L equals W. Notice that's not the same thing as I got whenever I did it incorrectly. So you're going to want to go here and definitely cross that out. That's wrong. But, you know, I wouldn't even do it this way. This is the way that I think is the best, because when students do it this way, they tend to not make the mistake that I showed you right here. So whenever you're solving for a variable and there's a coefficient that you're going to have to divide by, I would recommend getting that term by itself. So I have P minus 2L equals 2W. And then I would divide after I add or subtract. So again, I would always add or subtract first before I divide, just because people make less mistakes then. I have found that to be true over the years. Now this is the same as this. You would get that same thing if you took this expression and divided each thing by 2. So I'm going to go ahead and write a hint down for you related to that problem. Okay, so I have a hint typed for you right, here, hint number 2. So can you jot that down? This is again what I just said before. If the variable is part of a term, always isolate the term first by adding or subtracting, then multiply or divide. Okay, so pause that if you need to write that down. Let's go to another example, and let's use this formula. This is example 4, I think. Yeah. Okay, so for example 4, we're going to use another geometry formula. A equals 1/2 height base 1 plus base 2. And hopefully you recognize this as the area of a trapezoid. We're going to solve for B2. So let's say we have this trapezoid, base 1, base 2, height. All right, so the variable I want is in parentheses here. So I have several things I have to get rid of in order to get B2 alone on one side of the equal sign. I have this half, I have H, and I have B1. So I would recommend getting rid of all this stuff on the outside first and then focus on the parentheses. Now here's what some people do, which isn't wrong, but it just doesn't look the best that it could. They think, okay, to get rid of the 1/2, I'm going to divide by 1/2 because right now 1/2 H and the parentheses are multiplied. So to undo multiplication, you divide. But then you have this area divided by 1/2, and that just looks too complicated. Like there's a way easier way to write this. So I would not do it this way. I would come over here, and you want to think, all right, instead of dividing by 1/2, what mathematical operation is the exact same thing as dividing by 1/2? And hopefully you're thinking, multiplying by 2 is the same thing as dividing by 1/2, because 1/2 times 2 is 2/2, which is 1. So all I'm left with on this side is really a 1, and now the 2 is on the other side, and 2a just looks a lot nicer than a over 1/2, and it's easier to write. So the variable I want now is still in parentheses, so let's get rid of this h. So now I have 2a over h equals base 1 plus base 2. And now I'm almost done. All I have to do is get rid of base 1, and since those two bases are added, I'm going to get rid of it with the inverse operation of subtraction. 2a over h minus b1. Do not put this denominator of h under b1 as well. It's completely separate. So b1 is not over h. That equals b2. All right, so I have another hint for that one, which you can write down with me in just a second. Okay, so the hint I have for you here is avoid complex fractions. Now, a complex fraction is exactly what we had right here. A complex fraction is a fraction inside a fraction. We generally don't want complex fractions, so you're going to want to avoid complex fractions by multiplying by the reciprocal. Now, it's not always possible to avoid a complex fraction, and the next example will show us that sometimes you do have to have a complex fraction, and sometimes that's okay. So I think I'm going to do one more example here. This is example 5, and then we'll call it a day. Example 5. How about I equals P times 1 plus RT? And let's solve for R. Again, we are looking for something in parentheses. So generally what I recommend here is getting the parentheses alone first. I would not distribute the variable P. You could, it definitely isn't wrong. The answer will look different, it will really be the same. So let me show you an example of when you will get a complex fraction, and that's okay. So to get parentheses alone, I have to get rid of this variable P on the outside. So because there's multiplication here, let's divide by P. So I have I over P equals, those cancel, 1 plus RT. So I'm still circling what I'm looking for, so I'm not going to go in an endless loop with a not without an ending. So now let's, the variable I want is part of a term. So let's add or subtract things first to get that term alone. Let's use one of the hints we just wrote down. I over p minus 1. Those are separate. They're not the same fraction. R, t. I'm almost there. R and t are connected with multiplication. So to undo that multiplication, let's divide by the variable we don't want. I don't want the variable t, so let's get rid of it. And notice I have just created a fraction, I over p, within this whole fraction. And there are ways to simplify it. And I think actually in this case, if you had distributed p first, you wouldn't have had a complex fraction. So I guess you could have distributed p. It really is a personal preference. I'm usually going to get the parentheses alone first. So here are 5 examples for you, and hopefully they help us whenever we do classwork together on Tuesday. All right, I lied to you. I hope this doesn't cause trust issues, but we do have one more example we need to get to, and I'm going to try and do it really quick. I try not to do videos over 15 minutes, but you know what? Because we have so little class time together, it is what it is. Can you write down the hint first? Hint number 4. And the hint says if the variable you want is in the denominator, if it's stuck in a denominator, you need to get it in the numerator, and the way you're going to do that is multiplying each side by it, which will get it on the other side. So pause, write that down, and then let me show you the last example for real. This is an actual formula from physics. I think it has to do with circuits and resistance, but we're looking for R2. Now, the biggest mistake I see, and I just want to point this out quickly, is that people think that they can reciprocate each term and get this, and then they're like, hey, I just have to subtract by R1. But that doesn't work because you have addition here. There's more rules with addition and subtraction. If that had been multiplication, yes, you could get away with that, but it's not multiplication, so you can't get away with that. What if I had the correct equation, a half minus a fourth equals a fourth? That looks really similar to this, except there's addition or subtraction here. That would be the same as saying like, all right, let me just reciprocate everything and assume that it's still true. Well, 2 minus 4 is definitely not equal to 4. So that's why we cannot just reciprocate each side. So please don't ever do that. Every year I have people try and do that, and it just doesn't work. So another thing I see people do is try and multiply each side by R2, but then they only multiply this term by R2, not this term. They're doing that thing where they don't do it to both things on each side. And again, that's also wrong. So let me show you the correct way. This is the most commonly missed type of equation I see. So we're going to have to practice this one more than the other types. What we're going to do is use that one hint that says, if the variable is part of a term, get that term alone first, using subtraction or addition. So I'm going to subtract by 1 over R1. So I have 1 over R minus 1 over R1 equals 1 over R2. Now I'm going to use the hint that I just showed you that says if the variable you want is in the denominator, get it in the numerator by multiplying each side by it. And you might be thinking, well, did that help? It looks pretty complicated still. And it does, but we'll get there. So now I have R2 times, do not distribute this. It will make it more complicated. I only have a 1 over here. So look, I want this R2. R2 is not involved in this parentheses really. There's multiplication there. So let's just divide by the entire parentheses. R2 can easily be isolated in this case by just dividing by the entire parentheses expression. And check it out, that whole thing just cancels. And R2 is alone. I definitely have a complex fraction. I have fractions within a big fraction, and we will practice simplifying that this year, but that is another story for another day. Okay, cool. So here's your final answer. And now we're finally done, and we will practice this together next time we talk.